In the previous lessons, Josh and Arobindo explored the growth of a beanstalk and modeled that growth using different types of representations. In this lesson, they apply their knowledge to a new context, mold growth. They will use logarithms to explore this growth and learn how logarithms can help us find exponents. They began by exploring how long it will take a slice of pizza to grow moldy.
We're going to a new context now. You and your partner are running a science experiment to see how long it takes a piece of pizza to grow moldy.
Why would you do that? Okay.
On the morning of your experiment, you place the pizza slice in a petri dish with 1 gram of mold. We call this initial time t = 0. You track the growth of the mold and see that the number of grams of mold increases by a factor of 3 each hour. Estimate, but don't solve for, the hour when there will be 50 grams of mold.
Oh, well, wait, we know that it's between 3 and 4, because 50 is between 27 and 81. And the plant just keeps on, the mold just keeps on growing.
Okay, so what are these numbers on the top? What do you think they are?
They are grams of mold.
Okay, and what's the numbers on the bottom?
The hours.
Okay, so 50 is somewhere between 27 and 81, so what does that mean in terms of time?
Well, it'll be in between hour 3 and hour 4.
You think it'll be closer to 3 or closer to 4?
I think it'll be around in the middle, maybe. I'm not sure.
The students had determined the pizza had 50 grams of mold somewhere between hour 3 and hour 4 because it had 27 grams of mold on hour 3 and 81 grams of mold on hour 4. Arobindo conjectured that it had 50 grams of mold about halfway between the 2 hours. To explore this conjecture, he will compare the factor by which the mold increased from 27 to 50 and the factor by which the mold increased from 50 to 81.
So, we're going times 3 over a day. An hour. I keep on saying day. Okay, we got a calculator. It's 1.8. I somehow already knew that, but I didn't know the numbers after that. Okay, and so this gives us times 1.85. So 1.85 is about, I don't know. Wait. Oh, we need to use, wait. Oh, so if we could get the number that 1.85 to the exponent is 3, then we would know about which one is close. Is it closer to hour 3 or hour 4? Because we have like a period of it growing of 3 to the... Wait, no. It's growing 1.85185. And it would be 3 to the something, because we're growing by like this 3 factor.
Okay.
So, but I think it's somewhere near the middle of it.
Okay.
Arobindo determined that the amount of mold increased by a factor of about 1.85 from when there were 27 grams of mold to when there were 50 grams of mold. He also thought about how to determine how much time had passed for the mold to increase by that factor. He seemed to think this might be the exponent you raise 1.85 to get 3, or the exponent you raise 3 to get 1.85. They will explore this more in a future lesson, but for now, the students will determine the factor by which the amount of mold increased from when there were 50 grams of mold to when there were 81 and compare this factor to 1.85. Determining which factor is larger will let them know if 50 should be placed closer to 27 or 81.
So we can do 81 divided by 50.
Okay.
81, 50.
And why are you doing 81 divided by 50?
Well, yeah. Because we did 50 divided by 27, which was, it's like 1.85 pretty much. Okay, 1.85, and that's like the growth factor from this day, hour 3 to where it becomes 50 grams. There's 50 somewhere here. And it's times 1.85 about. And this one is exactly times 1.62.
Is that telling you it's going to be closer to hour 3 or hour 4?
It's going to be closer to hour 4.
Why is that?
Because the multiplicative factor is lower from the 50 grams to the 81.
Mm-hmm.
In this episode, Josh and Arobindo estimated when there would be 50 grams of mold on their slice of pizza. They used a number line to help them explain their reasoning. First, they reasoned that the hour would be between 3 and 4 because 3 to the third power is 27 and 3 to the fourth power is 81. Then, they narrowed their estimate by comparing the factor the mold increased from 27 grams to 50 grams with the factor the mold increased from 50 grams to 81 grams. These factors were 1.85 and 1.62 respectively. This means the mold increased by a greater factor from when it had 27 grams to when it had 50. This means more time had passed and the time when the pizza had 50 grams of mold would be closer to hour 4 than to hour 3. In the next episode, they will determine the exact time.